And I'm also going to put in the show notes a link to my website so that with a study guide. So any of you teachers out there want to be able to go to professorjrod.com/downloads, look for the episode that you want to download, click on it, you'll download a study guide, and you can give it to your students as homework assignment. Have them listen to the podcast and then answer the questions that are on there. Or, during Christmas break, you could give them assignments and on the podcast and then use the study guide for the questions or just this episode, cloud and resources that they can use over the winter break. Tap in. Hi, this is Professor J. Rod. Welcome to Technology Tab. For those of you not familiar with this podcast, in this podcast I try to help my students with their A+, Network Plus, Security Plus, and coming soon, Tech Plus. So if you want to follow me, you can follow me at Instagram at Professor J. Rod, at TikTok at Professor J. Rod, LinkedIn, look me up under Professor J. Rod, and I'm also, if you want to buy me a coffee, those who know me know that I love coffee. You can go to buymeacoffee.com/Professor J. Rod. And I'm also going to put in the show notes a link to my website so that with a study guide. So any of you teachers out there want to be able to go to professorjrod.com/downloads, look for the episode that you want to download, click on it, you'll download a study guide, and you can give it to your students as homework assignment. Have them listen to the podcast and then answer the questions that are on there. Or, during Christmas break, you could give them assignments on the podcast and then use the study guide for the questions or just resources that they can use over the winter break. All right, on this episode, we're going to talk about cloud and virtualization. There was a time when every computer program lived inside one machine, one hard drive, one building, one locked server room. But today, your data can live in Virginia, Oregon, Ireland, Singapore, and a backup copy in another hemisphere, all at once. Welcome to the age of cloud computing. Today, we're going to do a deep dive into cloud and virtualization security, one of the most important domains of the CompTIA Security Plus exam. This is the story of how computing left the building, how virtualization reshaped infrastructure, how security followed behind at full sprint, and why misconfiguration, not malware, is the number one cloud threat. Let's tap in. What is cloud computing really? Cloud computing is defined as on-demand network access to shared pool of configurable computing resources. Those resources include servers, storage, database, networking, applications, analytics, and intelligence services. And the organizations that sell these, they are called cloud service providers. For example, Amazon Web Services, Microsoft Azure, Google Cloud Platform, Oracle Cloud, IBM Cloud. Cloud computing exists because it solves four massive business problems: elasticity, scale instantly; scalability, grow without rebuilding; pay per use, no capital hardware costs; and resiliency, fail over automatically. Or in plain English, you don't buy the data center, you rent the power of one. The four types of cloud. Security Plus exam requires you to master four cloud types. Public cloud, owned by a provider, shared infrastructure, internet access, cheap, highly scalable. Examples: AWS, Azure, Google Cloud. Security risk, their multi-tenant exposure and misconfiguration. Private cloud, owned by one organization, on-premise or hosted, high control, high cost. Security advantage, full control of data. Community cloud, shared between similar organizations, example, hospital, universities, financial institutions, security focus, regulatory compliance. And hybrid cloud combines public and private, most common real-world deployment, used for burst computing, backup, disaster recovery, sensitive workloads. Biggest security challenge, data movement between trusted zones. Cloud locations and decentralized computing. Cloud computing is not centralized. It operates in a decentralized geographic model. This means regions, availability zones, redundant replicas, global load balancing, security implications, and an outage in one city no longer means a system-wide outage unless your security architecture is poorly designed. Cloud architecture concepts. In the Security Plus exam, there are three major architectural technologies that dominate. One is the thin client. A thin client has no processing power, boots from cloud servers, and stores no permanent data. Security advantage, stolen device equals no stolen data, right? Because everything's on the cloud. There's nothing on the client. Transit gateways connects multiple VPCs, data centers, branch office, VPN. Security risk, single misconfigured gateway can expose the entire enterprise. Serverless infrastructure, also called function as a service. You deploy code while the provider manages servers, RAMs, OS, and patching. Security advantage, reduce attack surface. Security risk, visibility of blind spots. And you have four cloud service models. These are the ones that are most tested on the exam. First one is SaaS, software as a service. You use email, CRM, office tools. You manage users, passwords, and the data. Vendor manages everything else. Example, Office 365, Google Workspace, Salesforce. Next, we have PaaS, platform as a service. You deploy your own application. Vendor manages OS, runtime, patching, database platform, and it's perfect for developers. IaaS, infrastructure as a service. You control the OS, the patching, the firewall, and the application. The vendor controls the physical hardware, and this leads to maximum flexibility and maximum responsibility. And XaaS, anything as a service, everything. Cybersecurity, DRaaS, DBaaS, IaaS, and storage as a service. Next, let's talk about cloud management and service providers. Cloud management can be handled by local IT staff, managed service providers, or managed security service providers. MSSPs provide 24/7 monitoring, SIEM, SOC, threat hunting, incident response, especially critical for small business, healthcare, education, and financial services. Monolith versus microservices. Monolith applications, one massive code base, all services tightly linked, one crash equals everything crashes. Microservices, small specialized service, each with its own log, authentication, database, and APIs. Faster updates, better scalability, more attack surfaces, and API security becomes mission critical. So we define deployment models, service models, cloud locations, microservices, and the business forces that pushed computing off physical servers and into the virtual infrastructure. Now we secure it, because the moment data leaves your building, trust becomes architecture, and architecture becomes survival. Cloud security, architecture, and control. The shared responsibility model, the most dangerous misunderstanding in cloud security. The number one cause of cloud breaches is not hacking, it's misunderstanding responsibility. Every cloud provider uses a shared responsibility model, meaning the provider secures the cloud, the customer secures what's in the cloud. Provider always secures the physical building, the power, the HVAC system, the physical server, the storage hardware, then the fiber backbones. You secure depending on if you're using IaaS, PaaS, or SaaS, identities, passwords, access control, encryption, data classification, firewall rules, patching, antivirus, and application security. Real-world breach problem. A company exposed millions of records because AWS secured the hardware, but the company left an S3 bucket public. No malware, no hackers, just misconfiguration. Identity is the new perimeter. In cloud security, the firewall is no longer the perimeter. Identity is. Cloud platform relies on identity and access management, role-based access control, least privilege, multi-factor authentication, and API tokens. Core IAM security rules, no shared admin accounts, no permitted access keys, MFA on all privileged users, role-based permission only, and continuously auditing. Breach scenario. An exposed API key in GitHub allow attackers to spin up servers and mine crypto and rack up $100,000 in cloud charges. Cloud security failures now cost money by the minute. Encryption in the cloud must be protected in 3 states. Cloud data exists in three different states. Data at rest, stored on disk, data in transit when it's moving across the networks, and data in use when it's being processed in memory. Cloud encryption best practice, AES 256 for storage, TLS 1.3 for transit, hardware security modules, key management services, and customer managed keys. Failure pattern. If attacker steals unencrypted cloud backups, full breach with no malware involved. CASB, the security guard between you and the cloud. CASB is the cloud access security broker. It sits between the user and cloud services. It enforces access policies, DLP, encryption, anomaly detection, malware scanning, shadow IT discovery. CASB protects against employees uploading data to personal cloud storage, weak cloud authentication, risky SaaS usage, and unauthorized file sharing. SASE, the future of cloud native security. SASE is Secure Access Service Edge. It converges VPN, Firewall as a Service, CASB, ZTNA, DLP, and web filtering into one cloud-delivered security platform. Why does it exist? Your users don't live on your LAN anymore, don't use your firewall anymore, don't sit in your building anymore. Security has to move where the users are. Virtual security, when one server becomes 100 servers. Virtualization allowed one physical server to become dozens of virtual systems. But now, one exploit, one escape, one hypervisor bug can destroy hundreds of systems at once. Virtualization threat landscape. VM escapes attacks, hypervisor exploits, snapshot theft, live migration interception, poison VM image, and memory scrapping. Security controls for virtualization, hardening hypervisors, signed VM images, segmented virtual networks, separated management planes, and encrypted snapshots, and also role-based administrator access. Containers and orchestration security. Containers, Docker, Kubernetes brought microservices, portability, and speed, but also image poisoning, insecure API, exposed architecture, dashboards, and supply chain malware. Container security requires signed container images, private registries, secrets management, API gateway security, runtime monitoring, and network segmentation. Hybrid cloud security, where most enterprises failed. Hybrid means an on-premise systems and a cloud systems connected via VPN or direct fiber. Hybrid security risks, data leakage between trusted zones, inconsistent identity policies, misaligned encryption, split monitoring tools, and visibility gaps. Here's a scenario. One on-prem server trusts cloud architecture incorrectly. Attackers pivot into internal network. This is how hybrid breaches spread laterally. Monitoring and logging in the cloud. You cannot secure what you cannot see. Cloud security depends on continuous logging, behavioral analytics, real-time alerting, centralized SEMI, and SOAR automation. Cloud logs include API calls, login locations, privilege escalation, file access, network traffic, configuration changes. Exam truth. If there are no logs, there is no security. All right, we talked about how we built the cloud, and we also talked about how we secure the architecture, and now we face the attackers, the laws, the failures, and the future of trust itself. Because in today's world, the cloud doesn't fail from fire or flood. It fails from leaked credentials, exposed storage, poisoned updates, and blind trust. This is the battlefield of modern cybersecurity. The most common cloud attacks in the real world. Cloud breaches today follow the same repeatable patterns. Public storage exposure, public S3 buckets, open Azure blobs, unsecure Google Cloud storage. Results, millions of records leak without a single exploit. The attacker didn't break in, the door was left open. 2. Stolen API keys and access tokens, hard-coded in apps, stored in GitHub, left in scripts. Result, attackers deploy crypto miners, exfiltrate data, or destroy environments. 3. VM and snapshot theft. Stolen disk image, unencrypted backups, deattached volumes. Result, complete system reconstruction by attackers. 4. Supply chain attacks. Compromised third-party libraries, poison updates, malicious container images. Results, attackers inherited trust access automatically. VM escape, the one that terrifies engineers. A VM escape occurs when an attacker breaks out a virtual machine and gains access to the host hypervisor. From there, they can view other VMs, inject malware, scrap memory, and steal encryption keys. Defense against VM escape is hardening hypervisors, patch kernels, hardware-assisted virtualization, strict VM isolation, and dedicated management networks. Zero trust in the cloud. Trust nothing, verify everything. Zero trust means don't trust users, don't trust devices, don't trust locations, don't trust networks. Verify every request. Zero trust requires multi-factor authentication everywhere, device health validation, continuous behavior analysis, microsegmentation, encrypted traffic only. In zero trust, the cloud isn't trusted, not even by themselves. Compliance and governance in the cloud. Cloud system must follow laws and regulations, not just best practice. Major compliance fireworks, HIPAA, healthcare, PCI DSS, payment system, GDPR, EU privacy, SOC, financial controls, NIST, government security guidance, and ISO 27001, internal security standard. Cloud governance control, data classification, retention policies, legal holds, audit trails, chain of custody, geofences. Security plus court truth. Compliance doesn't make you secure, but ignoring it guarantees failure. Multi-cloud security, the next major challenge. Multi-cloud means AWS, Azure, Google Cloud, all at once. Risk, inconsistent identity access management, tool overload, unmatched logging, duplicate secrets, broken visibility. Solution, centralized identity, unified SEMI, SASE, and cross-platform CSPM tools. The human factor, how most cloud breaches actually start. Nearly all major cloud breaches begins with phishing, MFA fatigue attacks, reused passwords, social engineering, and admin overprivileging. The cloud doesn't fail first. People do. The future cloud security battlefield. In the next decade, it will focus on AI-driven attacks, automated defense, quantum-resistant encryption, confidential computing, sovereign clouds, encrypted memory processing. And the war won't be fought with firewalls alone. It will be fought with automation, behavior analysis, machine speed defense, and trustless design. All right, that'll do it for this chapter. Now, on to the 4 CompTIA Security Plus questions. You know how we do it. I read the question, then I read the 4 multiple choices, then I read it again. I give you 5 seconds, and you try to see if you can guess the right answer. Question number 1. An organization stores customer backups in encrypted cloud storage, but attacker steals the encrypted keys from a compromised administrator account. Which security failure occurred? A. Weak cipher selection. B. Broken access control. C. Lack of tokenization. Or D. Missing data masking. Read it again. An organization stores backups in an encrypted cloud storage, but attackers steal the encryption keys from a compromised administrative account. Which security failure occurred? A. Weak cipher selection. B. Broken access control. C. Lack of tokenization. Or D. Missing data masking. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the answer is B. Broken access control. Encryption is useless if attackers can access the keys. The real failure is improper identity access management protection of encrypted keys. The protection of encrypted keys. Question 2. Which technology acts as security enforcement point between the users and the SaaS application? A. VPN. B. Firewall appliance. C. Cloud access security broker. Or D. Packet shaper. I'll read it again. Which technology acts as security enforcement point between users and SaaS (CaaS) applications? A. VPN. B. Firewall appliance. C. Cloud access security broker. Or D. Packet shaper. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. The answer is C. Cloud access security broker. A CASB enforces policies, DLP, encryption, and access control between users and cloud services. All right, we're halfway there. Hopefully you're 2 for 2. All right, question number 3. An attacker successfully compromises one virtual machine, then gains access to the hypervisor, allowing control of other guest systems. What type of attack occurred? A. Container break. B. Lateral movement. C. VM escape. Or D. API injection. I'll read it again. An attacker successfully compromised one virtual machine and then gains access to the hypervisor, allowing control of other guest systems. What type of attack occurred? A. Container break. B. Lateral movement. C. VM escape. Or D. API injections. I'll give you 5 seconds. Think about it. 5, 4, 3, 2, 1. The answer, this is an easy one, right? You should have gotten this one right. The answer is C. VM escape. VM escape occurs when an attacker breaks out of a guest VM and compromises the host hypervisor. All right, last one. Which security model requires verification of every request regardless of network location? A. Defense in depth. B. Trusted perimeter. C. Role-based access. Or D. Zero trust. I'll read it again. Which security model requires verification of every request regardless of network location? A. Defense in depth. B. Trusted perimeter. C. Role-based access. Or D. Zero trust. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And of course, the answer is D, zero trust. Zero trust assumes no device, user, or location is automatically trusted, even inside the network. All right, hopefully you went 4 for 4 and you got them all right. Listen, these questions, of course, we touch upon the topic right before I give you the questions, right? The key is try to listen to the questions, a week later when you already listened to everything, and just listen to the questions, see if you get it right. That's the real knowledge if you're ready to take the exam. All right, let's close this up. The cloud is no longer the future. It is the present foundation of business, healthcare, government, education, entertainment, and global communication. But every advantage brings responsibility. Cloud security is not about castles and moats anymore. It's about identity, visibility, automation, verification. This concludes our podcast on cloud and virtual security for the CompTIA Security Plus exam. I'm Professor J-Rod, and remember, stay vigilant, stay adaptive, and as always, keep tapping into technology. This has been a presentation of Little Cha Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. And you can follow me at TikTok at Professor J-Rod, that's J-R-O-D, or you can email me at ProfessorJrod, J-R-O-D, @gmail.com.